Next, let's discuss the operation of the converter based on the conduction range. According to the graph, S1 will conduct current within this conduction range. At this moment, S2 is turned off. By analyzing the circuit, we can obtain these following equations for the output voltage and current of the converter. According to the equation, we can see the wave shape of both output voltage and current is following the supply voltage waveform. Next, when S1 turns off at pi, we can see S2 will turn on within this conduction range. We can obtain these following equations, where from these equations, we can see the wave shape of both output voltage and current is still following the supply voltage waveform. Thus, we can sketch the output voltage and current waveforms as follows. As you know, the average voltage of the AC waveform is always 0. Hence, we will discuss how to calculate the RMS value of the output voltage only. As usual, we will start with the general equation. Before we solve this equation, we can see that the property of the output voltage waveform is a half-wave symmetrical. Thus, we can consider the half cycle of the waveform to calculate the RMS voltage value. Next, we will study the effects of different firing angles using a simulation work. In this simulation, I will use two firing angles which are 50 degrees and 100 degrees. We will see the effects of these firing angles to the wave shape of output voltage and current waveforms of both AC voltage controllers and also the RMS output voltage values. Based on the wave shape of the output voltage and current waveforms in the second and third graph, we can know that the small firing angle has caused the AC source connected to the load longer than the large firing angle. As a result, the RMS output voltage using the small firing angle is higher than using the large firing angle. We can conclude that the RMS output voltage is inversely proportional to the firing angle values. Next, we will discuss the effects of inductive loads using simulation work. To make sure the AC voltage controller can supply the inductive load successfully, we must make sure that the minimum firing angle of S1 should be within the allowable conduction range. I will show in the simulation what will happen when the converter does not work in the allowable conduction range. In this simulation, the load impedance angle is 38.2 degrees. So, for the first converter, I use 35 degrees. And for the second converter, I use 60 degrees firing angle. From the simulation results, we can see the converter using the 35 degrees firing angle is unable to work as the AC voltage controller since the output voltage waveform is precisely similar to the supply voltage waveform. However, when the converter is controlled using 60 degrees firing angle, the converter can work well to regulate the output voltage waveform. Therefore, it is essential to ensure that the converter works within the allowable conduction range only. Nevertheless, due to the inductive load, we can see the wave shape of the output current waveform is not following the output voltage waveform.